Hello everybody. In the previous lecture we have started the chapter number 5 oscillation. In that we have seen the linear simple harmonic motion, after that differential equation of SHM, and then extreme values of velocity, acceleration, displacement, and expression of velocity, acceleration, and displacement respectively, and also the differential equation. Okay, now we will see what is amplitude. So what is amplitude? Amplitude is the maximum displacement of a particle performing the SHM during the means during the simple harmonic motion. When it's performing the simple harmonic motion, it performs the maximum displacement from its mean position is called as the amplitude. For that, only not this much is not considered. If the question is asked in your exam, then you should write that consider a line mn, and then on that the point O is at the mean position. On the board you can see this is the point O is the mean position of the mn, and the suppose this is the pendulum. If suppose this is the pendulum, and this is the mean position of the pendulum, and it swings here and here and here in this way, like this, it oscillates in this way. So we call this point as a mean position. That's why the mn, from mn, the o is point O is the mean position, and p is the point which is performing the simple harmonic motion, and the distance between the O and p is x. And we know the value of x. X is equal to a sine omega t plus x, omega t plus phi, where phi is the constant. And if suppose the the value of the sine omega t plus phi is equal to plus or minus 1, or plus or minus 1 or maximum, then x is equal to a, means the distance a is maximum. Okay, this is the amplitude of the simple harmonic motion. Now we will see what is the period of the simple harmonic motion. Now we will see. Now we will study what is the period of a SHM. Okay. Previously we have studied what is amplitude of a SHM. Now we will study what is first the definition of the period of the SHM. In this language only, in this scientific language only, you have to write in the exam. You may understand in your own words. Okay, whatever it may be, you can understand it in your words, but while writing you should write in this scientific words only, then and then only you will get the marks. Okay, so what is the definition is the time taken by the particle performing to complete one oscillation is called the period of a SHM. Means the time taken by a particle to complete the one oscillation during the SHM. Suppose the pendulum is starting from here, and from here the mm, uh, particle started oscillating here, again comes here, then again here to here, like this it oscillates. So When it starts from here to again comes here, then it completes one revolution. Okay, after completing one revolution, this is called as a period of a simple harmonic motion. So the displacement, first we know what is the displacement of the simple harmonic motion is x is equal to a sine omega t plus phi. This equations you should by hearted. Okay, you should learn it because in the worded problem the it may these equations may be very helpful to you. Okay, so you should learn it that. So after time t, so the displacement of a particle is x is equal to a sine omega t plus phi. Just now I told that. Now after time t, t is equal to t plus 2 pi upon omega. What is that? X is equal to a sine omega t plus, then I am substituting this value t plus omega t plus phi. Okay, then which is equal to a sine omega t 2 pi omega plus phi. Okay, then a which is equal to a sine 2 pi omega t plus phi. I am taking this 2 pi this side and omega t in this side. If here it is cos 2 pi, then there will be changes. Here it is sine omega sine 2 pi, so there is no changes. So the answer is x is equal to a sine omega t plus phi. Okay, then time period t is equal to 2 pi upon omega and k is equal to, we know, m omega square. From here we can write as omega square is equal to k upon m, and f is equal to kx considering only the magnitude. Okay, and k from here, then k is, I can write as k is equal to f upon x. Further we will solve as omega square is the in your textbook it is given as omega square is force per per unit displacement divided by mass. Okay, then which is equal to acceleration for unit displacement. Okay, which is equal to k upon m, and which is this now equal to again acceleration per unit displacement. Acceleration 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 per unit displacement. Okay, then t is equal to, now we have to find the t is equal to time period t is equal to 2 pi upon 2 pi upon acceleration for acceleration for per unit displacement. This same. Okay, then got it. This omega square is equal to, from here we have to find the value of t. Here we have to solve the value of x. Here a sine omega t plus phi, then t is equal to 2 pi upon t, k is equal to m omega square, then omega square is equal to k upon m, and this, and omega square is force per unit area upon displacement upon mass, and it is equal to k upon m, and which is equal to acceleration per unit displacement. Now t is equal to 2 pi upon acceleration per unit displacement. Then further, which is equal to 2 pi, which is equal to 2 pi upon under root k upon m. And now this is, which is equal to 2 pi upon, this will become in inverse, m will be on numerator and denominator will be k. So this is the value of the period of the SHM. Okay, which is 2 pi into under root k upon m upon k. Here it was 2 pi upon acceleration per unit displacement was k upon m. We have substituted here k upon m, then it becomes, 2 pi, 2 pi under root m upon k, because this goes in this side, then it becomes this. So t is equal to 2 pi under root m upon k. Okay, now we will see what is frequency. Now we will study what is the frequency of SHM. In the frequency of SHM, the definition of the frequency of SHM is the number of oscillation performed by a particle performing SHM per unit time is called as a frequency of SHM. Means the number of oscillations. किती ऑसिलेशन त्यांनी परफॉर्म केले SHM करत असताना सिंपल हार्मोनिक मोशनच्या वेळेस त्यांनी किती ऑसिलेशन कंप्लीट केले एका पर युनिट टाइमला, त्याला आपण फ्रिक्वेन्सी असं म्हणतो. म्हणजेच काय, n इज इक्वल टू, आपल्याला सगळ्यांना माहिती आहे n इज इक्वल टू 1 अपॉन टी. सो आपल्याला सेपरेटली त्याची व्हॅल्यू डिराईव्ह करायची काही गरज नाही आहे. आपल्याकडं कॅपिटल टीची व्हॅल्यू ऑलरेडी आहे, त्याला फक्त 1 अपॉन टी करायचं आहे. तर n इज इक्वल टू काय, नंबर ऑफ ऑसिलेशन अपॉन टाइम. तर नंबर ऑफ ऑसिलेशन n इज इक्वल टू number of oscillations upon time. तर number of oscillation 2 pi upon t ची व्हॅल्यू काय आहे आपल्याकडे m upon k under root t upon m upon k. तर आपण हे ह्याला इन्व्हर्स केल्यावर 2 pi upon k upon which is equal to 2 pi into under root k upon m. हे झालं आपलं फ्रिक्वेन्सी ऑफ SHM. मीन्स आपलं ॲम्प्लिट्यूड ऑफ SHM झालं, आणि पिरियड ऑफ SHM झालं, आणि फ्रिक्वेन्सी ऑफ SHM झालं. एक्सप्रेशन्स फॉर द A, V आणि X झालं, एक्स्ट्रीम व्हॅल्यूज झालं, आणि व्हॅल्यूज ऑफ म्हणजे आपले त्याचे व्हॅल्यूज सुद्धा आपण डिराईव्ह केले, ॲक्सेलरेशन, व्हेलॉसिटी आणि डिस्प्लेसमेंटचे, बरोबर. आणि डिफरन्शियल इक्वेशन ऑफ SHM पण केलं. आता आपल्याला फेज स्पेस फेज इन SHM बघायचे आणि त्याची केसेस बघायचे. बरोबर. आणि त्यानंतर आपल्याला सिंपल पेंडुलम आणि सेकंड पेंडुलम बघायचं आहे आणि अशा पद्धतीने हा चॅप्टर पण आपला संपत आलेला आहे. ओके, थँक्यू.